Okay, so single stage extraction. Okay, there are a few things that you need to know. Okay, first is to label your schematic diagram. Okay, so we are using L naught. We are using L naught as our feed, L1 as our raffinate, V1 as our extract, and V2 as our solvent. Okay, so the symbol for the weight fraction is based on the symbol of a stream that you have. So if you were to have V, so the fraction is Y. The weight fraction is Y. Okay. If you're using L, the symbol for the weight fraction is X. X, yeah? Okay. But please do not confuse. We are dealing with liquid. Okay, all are liquids. All right. So because all are liquids, even though the symbol is V for the stream, for the extract stream and solvent stream, they are in liquid form. Liquid form. So all of the streams that you have here, 4 streams, the components that you have must be in liquid form. Okay, because they are liquids. Okay. So if you're dealing with multiple stage, okay, if you're dealing with multiple stage, only V2 will become Vn plus 1 and L1 will become Ln. Okay, so for the component or solute component, we're going to use A, okay, A as our solute, B is the carrier. Normally you combine with the solute, and then C is your solvent. Okay, solvent is used to extract your solute from the feed solutions. Okay, so your feed solution, okay, if you were to have your feed solution, so let me show you here. Okay, so if you were to have your feed solution, since this is L, the weight fraction should be labeled as X, A naught, X, B, and then XC naught. Okay. For L1, X, A1, X, B1, X, C1. Okay. For V2, you're going to have Y, A1, A2, Y, B2, Y, C2. Okay. And then for V1, you're going to have Y, A1, Y, B1, and then Y, C1. Okay. Now, so that is relevant to the stream that you have. The stream that you have, the symbol of the stream that you have. Ada yang masih nak admit kenapa ni? Masih ada yang tak masuk. Okay. Now, okay. So, what is very important for LLE? Okay, since you are using the graph, okay, you are using the graph. So look at this particular graph. Okay, you at this particular graph. Your x-axis is represented by XA and YA. Yeah, XA and YA. And then your y-axis represented by XC and YC. Yeah? So this is the solvent axis. This is your solute axis. Yeah, solute. Okay. So if you were to have your XA, so this is your XA. Yeah, XA, XA. So the information of X coordinate for this particular solute exist come from XA. XA. Okay, all right. And then the x-axis, which is your solute axis, also represented by YA. This is YA, this is YA. So the x-axis is normally represented by two types of X and two types of Y. Okay? Two types of X, two types of Y for the solute. So, you akan ambil yang solute sahaja adalah solute yang ini. Okay, so ini semua koordinat X. Okay, coordinate X. Alright. So if you were to have for Y coordinates here, Y coordinates, so this is solvent coordinates. Okay, solvent coordinates. So the value of the coordinates is given by solvent. Okay, so you akan nampak lah kat sini solvent. Okay, yang dekat sini adalah solute. Okay, alright, so jangan confuse lah. Alright, so when you talk about this particular graph, which is a biphase ternary diagram, okay, two-phase ternary diagram, if you know your A, you should know your C, and then at the same time, it is automatically you know your B, okay? Because the total of the fraction should give you a value of 1, okay? So this thing, if you total everything here, you total everything here, it should be equal to 1. Okay. So in the LLE, we are dealing with weight fraction, weight fraction. Okay, not mole fraction, just weight fraction. Okay, and then in the LLE, okay, once you know the components that you have, okay, the weight fraction of the components that you have, you should be able to include that in your schematic diagram. So if you know your YA for the V1, so please put YA equal to what value at your schematic diagram. So there are few things to be asked for your exam. So normally they will ask you about draw the schematic diagram only. So if you want to draw the schematic diagram, so just include these V1, V2, L0, L1, S, E, F, R. Okay. But if you are required to draw the schematic diagram and label the information, so you need to include the information that you have in the schematic diagram other than the label of the schematic diagram. Okay, so I need you to understand that. Okay, all right, so all information here should be in fraction. Okay, in fraction, not in percentage. Information given to you is the weight percent, but when you transfer the information in your schematic diagram, use the weight fraction. Yeah. Okay. All right. So any question?
No, Miss.
No, eh? Okay. Tak ada. Alright, simple kan? Sebab you dah belajar dah sebelum ni. Okay. Now, next is to understand the material balance. Okay, so we are dealing with material balance. For this separation process subject, we are dealing with material balance only. So there's no reaction to take into consideration. Everything is about the mass balance only. Okay. Okay. So you are given the overall mass balance. All right. Okay. So this, let's say this is one equation, not the first row of the equations that you have here for overall mass balance. One row of this particular equation will give you three equations. Okay, three equations. Okay, same thing as what you have learned in your distillation. Oh no, in your gas absorption. All right, distillation is only binary, binary components. Okay, but for gas absorption and liquid extraction, we're dealing with ternary. Ternary. Okay, so you have three species. So if you have binary, you deal with overall mass balance and mass balance on component A. So this is binary only. Okay, but for the ternary, you have three components, so you need to have overall mass balance and mass balance on component A and mass balance on component C. So we are concerned about solute and solvent only. Okay, so don't bother about the carrier, which is your B, because once you know your A and B, you should know your A and C, you should know your B. Okay, if you have three unknowns A, B, C, you know two unknowns, you know the two parameter or two variables, you should know the other parameter or the other variable. Okay, so how to read this? Okay, so this is kind of revision to you lah. Okay, some of you are familiar with this already. Okay, so you have L naught V1, L naught plus V1 equal to L1 plus V1. You get one equation. If you have L naught plus V1, L naught plus V2 equal to M, you have the second equation. Okay? And then L1 plus V1 equal to M, you have the third equation. Same thing down here, L naught X A naught equal to M X A M. You have one equation, two equation, three equation. So basically, even though you're dealing with overall mass balance and mass balance on component A and B, okay, actually you have 9 equations here. Okay? 9 equations. 9 equations, you might have 9 unknowns. And it should be able, you should be able to solve 9 unknowns with the given 9 equation. Okay. Alright. Sebenarnya you ada banyak equation to be used to solve the unknowns. But in liquid extraction, we normally don't use much this particular equation. We don't use much lah. Normally we use only few. Okay. Because we are more on using the information and then solve the problem graphically, using the graphs. There are three to four types of graph that you need to know how to use. Okay, one is called the the triangle diagram. Two types of triangle kan yang kita dah revise. So, but what we're going to use in the exam, in our syllabus, is only right angle triangle diagram. Right angle triangle diagram, where you have two axes only, A and C. Okay, A and C. So jangan terbalikkan ya. Kalau terbalik, sebenarnya tak ada masalah untuk you letak A dekat sini and then C dekat sini. But the curve also terbalik lah. Curve pun akan terbalik dalam shape yang berbeza sedikit. Bentuk dia berbeza sedikit. But what we're going to use now is for the x-axis represent solute axis, and then y-axis represent the solvent axis. Okay. All right. Now I'm going to teach you the technical part, the skills that you need to have in order for you to understand much better on this particular graph. To understand on this particular graph. Okay. All right. Saya copy dulu. Okay, let's see this graph yang ada kat atas ni. Okay. All right. For you to easy remember on how to do the technical method, okay, technical using the graph or graphical method to solve the problem. So you need to memorize some things here. For LLE, so jangan mix confused with the gas absorption, because every topics that you have learned, there is one method, special method to solve the problem. Okay, so jangan confuse untuk gas absorption pula. Okay, so let's say here. Okay, so you have seen this. You have, if you have your textbook, your soft copy of the textbook or ebook, or from the Google. Okay, so normally you can see this type of graph. Okay, where you need to draw the L naught and then connect with your V2, which is your solvent. Okay, and then you have M inside here. Okay, what is M? Okay, so for this particular graph, there are areas to be labeled. Areas to be labeled. One is to label the stream coordinate. Label the stream coordinates. All right. Okay. So this is the stream coordinate V1, V2, L1, L0. Stream coordinates. And then you need to have a mixture coordinates. Mixture coordinates. And the label is, the coordinate is XAM, XCM. Okay, so that's the label for this. Okay, so since this is 2-dimension, it doesn't have to be, when you add XCM plus XAM, you get 1. So that is not the case. So the maximum that you get is 1, but it can be less than 1. So XCM plus XAM, you can get 1 or less than 1. But if you look here, L0, all right, L0 is here. So the value that you get is only less than 1. Okay, because for the solvent it's 0. For the solute, it's less than 1. The value of 1 is here. Okay, so you get less than 1. Okay, not more than 1. Okay, so do not confuse it. So you have to label the stream coordinates. Label the stream coordinates. Okay, and then label the mixture coordinates. Next is to label the area that you have. The area that you have here is called two faces, inside or under the graph. Okay, you have two faces here, and then outside is single face. Okay, in the two-phase area, separation is not done completely here. Okay, inside this graph. Okay, inside the curve. Okay, so this is the mixture. So if you look at the schematic diagram, how to get your M? You need to connect L0 with your V1, V2. The feed is connected to your solvent. Okay, along the way of this particular line, you're going to have a mixture. You're going to have the mixture along the way here. Okay, and then you need to connect your raffinate with your extract. So along the way, you're going to have the coordinates for the mixture. But the intersection between the two lines is called the coordinate for the mixture. Okay, so now let's look at this particular graph. Look at that particular graph. Okay, so look at the line given to you. L naught, you draw through your V2. L naught to V2. L1 to V1. L1 to V1 pula. Apa tu? Yeah, L1 to V1 or raffinate to your extract is connected. So you can have the intersection of the two lines, you get the coordinates for your mixture. Okay, so just remember you need to cross these particular two lines to get your M. Okay, all right. So if you have your L1, you have your M, you don't have to know your the information for V1 shouldn't be always given to you. If you know your L1, you know the M, the information for V1 should not be always given to you. Okay? So what you need to know, if you want to find the information on V1, you just extend the line from L1 to M. So you have L1, you draw to M, and then extend the line. Okay? Extend the line. The intersection of the line with the equilibrium line will give you the coordinates for V1. So if you know the coordinates of V1, you should know the the weight fraction of YA1 and the weight fraction of your solvent at V1. So by having that, you should be able to solve your YA1 and YC1 from the graph. You don't need to use the equation to solve the problem. Okay, just draw vertical line to get your YA1 and then with horizontal line to get your YC1. Okay, if you were to have L1 with your M. Okay, so just remember, okay, this particular techniques. Okay, so M can lie anywhere in this line. Okay, all right, and this particular line. But the place where it's intercept will represent the exact location of M or the mixture that you have. Okay, so that it will give you XAM, XCM. And then definitely you should know your XBM. Okay, any question? You can turn on your mic if you have questions. Are you alert? Alert semua ke tertidur dah?
Alert.
Alert, okay. Alright.
Miss.
Yes.
Saya nak tanya.
Yes.
So maksudnya tak semestinya kita boleh, maksud saya tak semestinya M tu tak diberilah dalam soalan untuk dapatkan V1.
Yeah. There are many types of possibilities that you get in the questions, okay? But you get all the information if you look everything. So you have to look overall situation given to you in that particular question first, and then analyze the questions, whether yeah, whether it is needed or
Okay.
not to use the material balance to solve the unknown. Okay.
Okay, understood, Miss.
All right.
Thank you, Miss.
All right. Okay. So actually, it's a best for you for if you can have the final exam paper and then analyze the questions. Okay. Analyze the question and try to solve the questions. Okay. By having these particular techniques first. Okay. Whether if you can use the graph to get the information, then use the graph. If you cannot use the graph to get the information, you need to use the material balance or equations to solve the problem. That's it. Okay. Because sometimes you need to solve for YA1, which cannot be solved using the graph. So in order for you to find YA1, you need to use the mass balance or material balance to solve for YA1. Macam itulah. So depends. So if the graph is given, use the graph first. Try to figure out what happened lah. Okay. All right. Okay. To get your operating point, you need to connect your raffinate line, your raffinate coordinates with the uh, with this one. Hold on. Okay. All right. So you need to connect your raffinate point to your solvent point. Okay. You need to connect R L1 to V2. Okay. And then you need to connect L0 to V1. So this is a single stage. Okay. Single stage. Kalau you have multiple stages, okay, the stream is labeled as Vn plus 1 and this one is Ln. Konsep sama je. Kalau multiple stages, just connect the point Ln to Vn plus 1. Ln to Vn plus 1 and then L0 to V1 to get your operating point. So this is operating point. Why is it important to have operating point? Okay, so remember the tie line. The tie line that you produce is called the stage of the extract column. Okay, so this is label. Take a look at this label. L1 to V1. Okay, L1 to V1 is called the first tie line or the first stage. So this is stage number 1. If you have L2 connect with V2, you're going to have stage number 2. Where if you were to have L3 connect to V3, you're going to have stage number 3. Okay, and this tie line will be the line that will meet at the operating point. Okay, so let's look here. L0 to V1. Okay, L0 to V1. So let's draw that one. L0 to V1. Okay, so this is L0. So you just draw from L0 to V1 the method to get the operating point. L0 to V1. Okay. So saya punya graph kecil je kat sini, mungkin tak muat. Okay, that is the line L0 to V1. Okay. And then L1 to V2. You just connect the line L1 to V2. Mana? L1 to V2. Okay. Alright. Tak kena sangat. Tapi dia punya cerita, okay, nak beritahu kat you, ialah dia akan meet, dia akan meet dekat hujung ni, dia akan intercept. That intercept is called the operating point. Dia akan intercept dekat operating point. Yeah? Okay. So kalau dia intercept dekat operating point, maksudnya you're going to use this operating point as the reference point to get the rest of the stages. The rest of the stages. Okay. So let me show you one of the example here. Untuk multiple stages. Just take a look. Okay. So this is the diagram. Hold on. Mungkin saya kena buang sikit dulu. Buang dulu supaya nampak. Okay. Alright. Take a look at that diagram. Diagram ni ada dalam your textbook or your PowerPoint slide. So L0 connect with V1. Okay. You extend the line. Lepas tu L1 connect with V2. L1 connect with V2 dan dia akan intercept. L1 ni, gambar tadi tu. So you kena buat betul-betul dan dia akan intercept. Kalau dia tak intercept, means that adalah something wrong with your calculation ataupun something wrong with the questions lah. So you just do that. Lepas tu, because these are the things yang you kena buat dalam graph. So this is graphical method. So the two lines always converge at one particular point yang kita panggil intersection point. And we call it as operating point. Okay, itu reference kita yang pertama. Okay, so from this reference point ataupun operating point, you should realize that L1 will lies and Ln akan lies dekat your layer here. Layer here. And V akan lies dekat this particular top layer. Okay. So this layer kita panggil, we call it raffinate layer. And then this one kita panggil extract layer. So that's why extract layer hanya ada V sahaja. And then raffinate layer hanya ada L sahaja. Except your L0 yang tak ada dekat sini. Why is that so? Okay. So that's why whatever that you collect at your product should lies on the equilibrium curve. So should be in equilibrium curve. All right. And then there is one point here. If you read the theory, the point is called plate point. Plate point, P-L-A-I-T. Plate point. Okay, one plate point. So the plate point is the separator, okay, or the separate point, a point to separate two layers. Okay, if this is your raffinate layer, so the other side should be your extract layer. Sorry. Okay, the other side should be your extract layer. Alright. So apa yang kita ada kat sini? Okay. So soalan ni tak semestinya untuk kita selesaikan everything, but this is to teach you how to solve some of the questions here. Okay. So you're given isopropyl IPA ether is used to extract acetic acid. Okay? To extract acetic acid. So if you were to have these questions, so isopropyl ether to extract acetic acid. So definitely you're going to have acetic acid as your solute. Okay, because that's the purpose of you using isopropyl. Okay? So this is called solvent. All right. And then the acetic acid is from an aqueous feed. Aqueous, aqueous meaning that you have water inside. So this is carrier. Okay, so normally it's water. Okay, from the feed. Okay, and then reduce the concentration of acetic acid to 5 weight percent. Okay, so dalam you punya feed ada A, ada B so far. C tak sebut pun lagi. Okay, and then it is mentioned here that the aqueous feed stream contains of 48% of acetic acid. So dia hanya bagi you XA0 equal to 0.4. Yeah. So this is weight fraction. Okay. And then that's all. Dia kata acetic and aqueous sahaja in aqueous form. So therefore yang you ada adalah XBO sahaja, which is 0.6. Okay. And then it's mentioned that this acetic acid concentration will be reduced to 5 weight percent. 5 weight percent, reduced to 5 weight percent. Okay, maksudnya semakin berkurang. Okay, so when you have semakin berkurang, it should be in your raffinate, because what you want, the solute that you want should be in your extract, not in your raffinate. Therefore, this information for 5 weight percent here represent by XA1 in your raffinate. XA1 equal to 0.05. Okay. All right. Okay. So let me show you that if you have your components A dengan B dekat feed, at raffinate you have A, B, or maybe C, or this one maybe C, but because this is aqueous in the feed, ni tak ada lah, C tak ada. Okay. And then if you were to have your raffinate always consists of a very little bit of your solute. Okay. Small amount of solute. Jadi A ni mesti yang kecil. Okay. And very large amount of your carrier, because the water that you have in your feed should be collected at your raffinate. And that should be a little bit of solvent, because most of the solvent should be collected at your extract. Okay, here. So you have A and C. So you're going to have your large amount of solute and your large amount of solvent in your extract. Okay, all right. So we want to assume sometimes that most of the water that you have, which is your LBO, okay, always collected here, where you have LB1 is equal to LBO normally. Okay, all right, and then at your extract VC1, okay, if little bit or no solvent collected at your raffinate, your VC1 here akan sama dengan saya dah terbalik dah. Okay, this one is V2 VC2. Okay, so that is your objective actually, to collect majority of your solvent in your extract, to collect majority of your solute in the extract, and to collect majority of B at your raffinate. Okay, all right, that's your objective actually. Okay, but we cannot get that 100% lah, 100%. Okay, okay, so when you look at these questions, all right, uh, you're also given this thing. Okay, so let's know first the mixture M consists of 28% and 65%. So that is actually, kalau nak tulis pun, this represent XAM equal to 0.2, XCM is equal to 0.65. The balance is XBM. Okay, so you need to use the graph. So saya pergi laju sikit. Harap bertenang. Let me copy first. Copy plus this. Okay. Okay. So you're using your graph. Soalan suruh you label. The first question answered already. First question answered already. So now you need to answer the second one, which is to label L0, Vn plus 1. Okay, now let's look at this. So it is given Vn plus 1. So yang ni sepatutnya kita label dia supaya tak confuse. Kita label dia V2. Sepatutnya V2 Okay. Kalau dia multiple stages, kita akan label dia Vn plus 1. Yang sini kita akan label dia Ln. Okay. So since in the question you are given the symbol as Vn plus 1, so you gunalah Vn plus 1 tu. So you have to use Vn plus 1 dengan Ln because it is given the symbol already. So jangan lawan soalan okay. But the only thing is that are we going to treat the questions here as a single stage or multiple stages? Itu je persoalannya. Okay. So if it's known that this is multiple stages, so you have to treat this as a multiple stages. If this is known as single stage, then treat this as a single stage. But if you don't know, normally if you don't know anything, whether it is single stage or multiple stage, just assume multiple stages first. Okay, so assume multiple stages if you don't know whether it is single or multiple. Okay, but if the question state that you need to find the number of stages, definitely it is multiple stages. Okay, so you should know that is a multiple stages already, so you use multiple stages. So if you don't know it is multiple or single, just use multiple. Yeah, so as easy as that. So you're given your L0 here, and then Ln, okay, even though you know your this one is your Ln kan, so jadi dia adalah simbol dia XAN okay, which is 0.05. 1, 2, 3. Okay, so this is the XAN, which is 5, 0.05. Okay. All right. So you tengok sini, from the graph, from the information, you only have XAN. Okay? You only have XAN. You don't have LB, you don't have B component or C component. But from the graph, if you want to know the value of C, okay, you just bawa je pergi sini, draw horizontal line. So that will give you the value of XCN. Okay, which is I think about 0.02. Okay? Jadi, you don't need to calculate using the material balance. Now you have your xcn is equal to 0.02 already from the graph. Okay, from the graph. And then you need to label your ln dah label. ln label lah. So dia nak ln kan. So label lah ln tu. And then you are given also your mana lagi? Pure. Pure. So your kalau pure y cn plus 1 is equal to 1. Pure. So kalau pure, dia duduk sini. So that is Vn plus 1, pure. Okay. So label, kita label lah. Okay. Lagi apa tak label? V1. Ada masalah V1? Belum tahu lagi kan? Okay. So let's say, dia bagi juga coordinates untuk M. This one. 0.2. 0.2. So you just cari 0.2. So these are the lines lah yang you ada. Okay. You ada line ni. Sorry. Ada line tu. Okay. Lepas tu 6.5. 6.5 is here. Jadi inilah you punya M. Kalau ikut soalan lah. Kita ikut je soalan. Tak tahu soalan ni betul ke tak kan. Hopefully tak ada masalah. Kalau ada masalah, tak ada masalah. Dia buat je. Okay. So now, kalau M dah ada kat situ, apa yang perlu ada? V1, sorry. Nak jumpa V1, ln ni kena lalu dekat M. ln kena lalu dekat M. Okay. ln ni kena lalu dekat M. So, you take your ruler from LM from LN lalu dekat M. Okay. Sebab kita tahu tadi dekat dalam gambar tu, if you want to know your V1, want to know your V1, LN ni kena jumpa dengan, kena lalu dekat M. M mesti ada somewhere here lah kan. Lalu dekat M untuk jumpa V1. So kita ada M, kita ada LN. So we just connect. So kat mana dia jumpa? Dekat sini kan. Kat sini. So that is V1. Okay. So tak perlu selesai pun masalah ni. If you were to find the composition of V1, ambil je coordinates tu. And then carilah apa dia YC1. And then turun kat bawah. Dapatkan dia punya YA1. Okay. Saya tak pasti. Ni estimate je. So you kena buat sendirilah nanti. Okay. So that's the estimate of YA1 dengan YC1. So kalau you want to find the information, the composition of the extract, which is YA1, YC1. So kalau in case mine, based on my calculation here, it should be 72.5. 72.5. Untuk C, 0.75, 72, 72 Sekejap. 725. 725. Okay, YA1 saya. Tengok yang kat bawah tu lebih kurang 22.5. 22.5. Okay, so I can get all the information. Okay, based on the graph. Tak buat pun. material balance. Okay, so I think that's about it. If you want to complete everything here, you just have to proceed on your YB1, which is the balance of the YA1 and YC1 to get 1.0. For the time being, I want you to have to practice on the final exam paper untuk this type of question so that you ada feeling. It's not everything, sometimes it's not everything that you can get from the graph. Sometimes you still need to do the material balance. But before you proceed with the material balance, try your best to get your answer from the graph using the graphical method. Okay, so don't waste your time using the material balance to solve the problem first. Okay, read the questions, the overall questions given to you, and then try to solve the questions using the graph or graphical method first. And then if you are not able to solve the problem using the graph, then you use the material balance. So this is applicable for the liquid extraction only, okay, where you have the alternative to solve the questions using graph or using material balance. But for the gas absorption, for distillation column, you need to use the graph together with the material balance, okay? So this is very special for the LLE. So if you get the information given here, so you should be able to solve the problem for LLE very easily, okay? Except that you need to understand on where to get your V1, V2, V3. So I haven't explained regarding to the stages yet because the graph is really complicated that I need to have another session to explain that to you, okay? But what you need to do, at least you know how to draw, to label L naught or your feed stream, your raffinate stream, your solvent stream, and your extract stream together with the mixture coordinates. Okay, so that is very important for the first step. And then for you to get the reference point, I've shown you already. So that reference point also called the operating point. Yeah, so there are two names given there. So you should be able to do that. So after you have done all of them, then it is easy for you to calculate the number of stages for LLE. Okay, so that's why this is a basic knowledge, basic skills that you need to have before you can proceed with the number of stages. Even though the question asks you to find the number of stages, you still need to do this particular method in order to solve the number of stages. But the number of stages is the last part of the questions, the skills that you need to have. Okay? Okay? All right. Thank you very much.